So we're still looking at some multi-step equations here, but we wanted to throw some in that could get a little scary. We know that the 3 steps are to simplify, to get rid of the constant, get rid of the coefficient. Sometimes you get ones that look like this, and you kind of just freeze where you're at. You get a little scared. So we're going to teach you guys how not to be scared of these things. We are actually going to unscarify this a little bit. All right, and we're still going to follow SADMEG, starting with our subtraction and addition and undo all that. But I would ask you first, looking at this equation, 2x plus 4, all divided by 5 equals 2, what makes that scary to you?
Divide by 5 is crazy. It looks like a scary.
Yeah, generally this right here, this big divide sign and divide by 5, right? That is usually what scares students away from approaching this problem, and they just say, I don't know how to start it. Well, I would argue against that. I think you do know how to do this problem. You're just scared and you don't want to attempt it because you might fail. Do it anyway. Try it. But here we are. We have this big divide sign. Let's go through SADMEG. Is there any subtraction and addition that I can do?
The 4?
Plus 4?
Yeah, and that's what a lot of people say. Well, can I undo the plus 4? The correct answer is no, we can't. Because remember, back in our order of operations and trying to simplify stuff, we said that numerators and denominators are their own grouping symbols. So because that's a grouping symbol, can I do anything inside that grouping symbol right now? No, it's stuck in the numerator, so I can't undo the addition or the subtraction here, right? So we are going to move on to undoing multiplication and division. You guys said earlier that there is division in here. Can I undo division?
Yes.
Multiplication property of equality.
The multiplication property of equalities. Now, that means I'm going to have to do something on both sides of the equation, so we're definitely going to need a lollipop. So we are going to be multiplying because we want to undo the divide. Now, we're getting rid of the scary thing right here. To undo divide by 5, we need to
multiply by 5.
Multiply both sides by
5.
5. Now, what does that do to these 5s here?
That's a 1.
That's a 1. So we got a 1 there. Okay, I'm going to bring everything else down. I've got 2x plus 4 left over.
And I don't need the 1. Huh.
Do you need the parentheses?
And that's actually a good question. Do we need to write down these parentheses?
No.
No, we don't. And why is that?
Because it's a 1, and 1 doesn't change it.
Yeah, there's nothing here to distribute in. These parentheses are all alone, so therefore they are not necessary. We don't need to write those down. Button. So we don't need those parentheses at all. We just have 2x plus 4 equals 10, and I bet you guys could probably solve it from here. So that one big scary problem that we had, we got rid of the scariness simply by multiplying both sides by this denominator and get rid of the division. So now we have 2x plus 4 equals 10. And I'm sure you guys could go from here by identifying the constant and the coefficient and getting rid of it. I'm going to keep on going through here, though. We're going to back up again and start because now we have a new problem to solve. We're going to start back from the beginning. Is there any subtraction or addition to
the 4?
Do? The 4. Now we can touch the 4 because there's no grouping symbols. How do you get rid of a plus 4?
Minus 4.
Minus 4. Now, normally, what would we do before we started doing any of this?
Circle the variable.
Circle the variable.
Underline the coefficient.
There's
touching it.
That's right, and?
Double underline the constant.
Because
that's
the
right.
plus sign separates it. It's like, I'm no coefficient.
And you'll notice that SADMEG does the same thing. We're going to get rid of the constant first by undoing addition or subtraction. In this case, we're going to undo plus 4. And then we're going to get rid of the coefficient by undoing multiplication and division. So let's back up to this.
You're a genius, Mr.
Oh, I know. Thank you.
Suck up, Mr.
How do you undo plus 4? How do you undo plus 4? Well,
Minus 4, subtraction property of equality.
the subtraction property of equality, subtracting 4 off both sides of the equation. Plus 4 minus 4?
0.
0. Bring down that 2x directly down so we can stay all nice and organized. 10 minus 4
6.
is 6. Now I still have a coefficient to deal with, but I'm up here doing SADMEG, moving on to the next thing, undoing division and multiplication. So how do I have any of that?
You divide.
Divide by what?
2.
Division property of equality.
That is correct. 2 divided by 2 is?
1.
1. So I have x equals?
3.
3. Would you have a look at that?
That's cool.
X equals 3. Not as hard as we thought it was going to be.
Now, having said that, I know there are going to be times when you're going to see a problem. By the way, go ahead, pause it, and write down the definition of distribution.
Distributive property.
I will do some Zen breathing while you do so. I'm just kidding. All right, so definitions. The distributive property is a way of simplifying that lets you multiply a sum or difference separately to form an equivalent expression. And what they're talking about here is sometimes when we do have grouping symbols, we're supposed to do, when we're doing simplification, we do something called GEMDAS, right? GEMDAS says I do grouping symbols first. Well, if I can't do what's inside the parentheses because x plus 2 doesn't add, then I have to have a workaround. Now, we could do, if we're solving and doing SADMAG, we could go ahead and divide by that -3 and get rid of the -3, and you can always do that. But if you choose to do the distribution property, which for some people, if it's the way they were taught, your parents may be helping at home and say, that's the way I was taught, then that's fine. You can do that. The way that we do that is simply like this. You take the number on the outside and you distribute. And so we can do it with arrow language. We're doing -3 times x, then -3 times 2. But the big mistake I see with students with this one is that they sometimes will distribute to the first term, but they forget to distribute to the second term. And so the way we have a workaround for that is something called an area model. If you notice, we have a term out here at -3, and inside the parentheses we have 2 terms. So we have a 1 by 2 square, right? That's our area model. And all we do, just like in a multiplication table when you were a kid, you used to have like 7 times 2, and you would go and where they matched up, oh, that's 14. Just like that, that's kind of how the area model works. I'm going to say -3 times x, oh, that's -3x. And -3 times 2 is -6. And so when I distribute this through, I end up getting -3x minus 6 equals 6. Now, I have simplified this equation using the distributive property. So I can actually solve. So now this is a simple equation of lollipop, boom, 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 which means I'm just going to circle the variable, underline the coefficient, underline the constant, right? And that's that 2, 1, 0 solve, right? So I go, oh yeah, how do I get rid of subtract 6? I do add 6, the addition property of equalities. That equals 0. That gives me 12. And I know I'm going fast. You can always pause the video if you want to kind of write it down. And then divide, to get rid of times -3, which is the coefficient, I have to divide. If I divide one side, I have to divide the other side. So that's the division property of equalities. Again, I know this says -3 and you want to go plus, but remember, the only way to get rid of a coefficient, if it's touching the variable, the only way to get rid of a coefficient is to multiply or to divide. And so -3 divided by -3 is 1, and I end up with x. And 12 divided by -3 is -4, because a negative times a negative is a positive. And so I end up with x equals -4. Now, again, if you're saying, well, I don't like that process, Mr. Craig, I think it sucks, you can always do SADMAG. So simplifying means we simplify, then we solve. But if we're going to go through SADMAG and not do the simplification, then the first step, as Mr. Nelson likes to do with his little arrows, or his little shapes here, we do subtraction and addition. I see an addition sign, but it's inside the grouping symbols. Well, grouping symbols don't come to the very end, so I can't do those. So I have to skip this step because there's nothing that I can add or subtract. The next step is to multiply or divide. Well, those parentheses, when something touches a parentheses, it means multiplication. So I have times and -3. So how do I get rid of times? Divide. I divide. But before I start that, I have to boom, boom, boom. My lollipop, it divides the equations into 2 sides so that when I do the properties, I'm making sure I'm doing them to both sides of the equation. So how do I get rid of -3 or times -3? I divide. Notice my line's super long because of my division. I'm dividing this entire side by -3. And I'm dividing this entire side by -3. -3 divided by -3 is 1. But I don't need to write that 1. I could bring down the x plus 2 in parentheses. But do I even need those parentheses anymore?
Nope.
No.
They're all alone.
6 divided by -3 is?
-2.
And so now I'm left with this. Now the last thing I need to do is get rid of those parentheses. And now I still have the same problem as before. The thing people forget about SADMAG is you go through the process, I get to grouping symbols, they drop. Then I start over again until I've simplified and there's nothing left. I keep on restarting. Every time I get to something and I do it, I start back over and see if I can keep the process going. So Can I do anything here? Yeah. Well, before we do that, though, Mr. Nelson pointed out that we like to circle our variable. So let's just know what side we're trying to get alone. Underline the coefficient. Uh-oh. Is there a coefficient here?
Yeah.
Well, yes, there is. There is a coefficient here. It's 1, but is that 1 really important to us?
No.
No. And then double underline the constant. Well, how do you get rid of plus 2?
-2.
And that's our first step there. So we say subtract 2, that's the subtraction property of equalities. That equals 0. And I don't need to write that 0. And so I bring down the x. I don't need to bring down the 1 because the 1 isn't necessary. And -2 minus 2 is -4. Both problems gave me an answer of -4. Again, I know that some people get mad because like, well, which way do we do it? We do whatever way you think is easy. If you look at a problem and say, you know what, I like to distribute. If you look at a problem and say, oh, fractions, is there an easier way? Then do that way.
All right, so this is just a similar approach to the other one. We do have this distribution, so you can go one of two ways. You can either simplify it first, or you can follow SADMEG from the very beginning. Let's switch it up and actually do SADMEG first this time. So we've got SADMEG. I almost forgot how to spell Meg. Okay, so then, lollipop. All right, so then, according to SADMEG, we are going to first start with our subtraction and addition. Now, this part right here is inside of the parentheses. It's the grouping symbol. Remember, we can't touch anything inside these parentheses until we get rid of everything else. So, subtraction and addition. Is there something on this side that we can subtract?
As I move from left to right, I see a 7. But is that plus or minus 7?
Well, this 7 certainly seems to be positive because this negative is attached to the 2. By the way, side note, this -2 is attached to the parentheses. You cannot do 7 minus 2. That is an incorrect first step that a lot of people make. So keep in mind what each term is attached to. This -2 is times our grouping symbol, so we cannot subtract them. But we can subtract that 7. That 7 is a positive 7, so let's go ahead and how do you get rid of a positive 7, guys?
Subtraction property of equalities.
Subtraction property of equalities. Subtract 7 from both sides because we got to keep this even. I'm the one that says seesaw. So 9 minus 7 is going to give us this positive 2, and then we're just going to bring down what we have left because this is now a 0. And do we need to write a 0? No.
That's my grade.
Which it very well might be for all I know. All right, so all we've got left is this -2 outside of our grouping symbol. So we're going to work on the next part of SADMEG, which is division and multiplication.
Where's the equal sign?
It's the lollipop, but fine.
Oh!
Lollipop stands for an equal sign for me.
Got you.
Regardless. So, we've already gotten rid of our subtraction and addition. Division and multiplication, like I said on the last step, this is a -2 times our grouping symbol. So, guys, how do I get rid of times?
The division property of equalities.
The division property of equalities. We're going to divide both of these sides by a -2. So on this side, we have a +2 divided by a -2. Positive divided by a negative is a -1. I'm going to make this lollipop a little bit longer. But that equal sign that Mr. Craig is so very fond of.
I get lost.
On the other side, -2 divided by a -2 is what?
+1.
You're both right. It's a 1. Sorry, Mr. Nelson, say that again.
You just have to write x minus 3.
Exactly. I just have to write x minus 3. Here's a tricky question, though. Do I still need the parentheses?
No, because we got rid of the...
Exactly, because we would have had the parentheses left, but remember there's that invisible 1 up front that we would distribute through. So the parentheses aren't needed because of this 1 up front. So I'm just going to get rid of those. Go over there for now. We'll deal with you later.
Go away.
Go away. You know what? Let's just banish it.
Yeah.
Banished. So then, now we have hit the very end of our SADMEG because we just got rid of our grouping symbol, which means what do we do from here?
Restart.
Restart. We got to start back at the beginning of SADMEG.
SADMEG.
Subtraction and addition. Do you see some subtraction or addition here?
Yes.
Yes, we've got a subtract 3. Everybody, how do you get rid of a subtract 3?
The addition property of equalities.
the addition property of equalities.
Well,
I
it's
feel
not just
sorry
plus
for
3.
that.
It's
What?
a property. It's not just plus 3. It's a property.
You are not wrong, sir. So we've got a 0 on this side, which we no longer have to worry about because I'm not writing plus 0. It's unnecessary. I've got an x left over here. This side, -1 plus 3. This is a positive 2. And we are done. That is our answer.
Is that our final answer?
It is our final answer.
But what about if I was putting it into Canvas or on a test?
You will see it one of two ways, really. This way is also completely correct. In fact, some might say it's more correct. Either
What
way,
property is that, by the way?
Mr. Craig.
why don't you tell us, Mr. Craig?
It's the symmetric property.
Symmetric property!
Sure, it's not the reflexive property.
That's only if I'm flexing.
Let's go back through this the other way as well. So we went through using just SADMEG. Now let's go through using, what was that? The simplifying first method. Is that a term? So I've got, you know what? I'm just going to clone this.
Oh, look at you using technology.
Almost like I have a smartboard or something. All right. Sometimes. So according to our other method, the first thing we have to do in order to solve an equation is to simplify. That includes distributing here. Now, this can be a little tricky when it comes to distribution. Please remember, this 2 is negative. It is attached to, or the negative sign is attached to that 2. So when we are distributing, it's -2 times x and -2 times that -3. I am confusing the swivel. Okay. Let's go ahead and solve this through. 9 equals the 7. -2 times the x just gives us a -2x. And then what is -2 times a -3?
Positive 6.
Are you sure, Mr. Craig?
I know it's not -5 because that would be adding like terms.
The next part is we're going to have to identify all of our terms. This is the part where we're going to identify our coefficients, we're going to identify our constants, and we are going to identify our variables. What is our variable? X, because it's the only letter that we have. So X. Now remember, the coefficient is the part that is touching the variable. In this case, it is our -2. And then the two constants, we have two constants. What do we have to do for them?
Simplify!
Simplify!
We're not done simplifying.
We're not done simplifying. Oops. Color consistency. So, what is 7 plus 6?
13.
Should I restart this?
I was wondering, yeah.
Let's go through, label these again. And now what is our one constant?
13.
13. There we go. Whew, that was almost scary. So then,
No, you're good. Sorry. Don't go on, Miss Kirkley. I apologize.
From here we're going from 2, 1, 0. First we got to get rid of our 2 underlines, which is our positive 13. How do you get rid of a positive 13?
Subtract 13.
Subtract 13 to both sides. This is a 0. -4 is over here, and -2x is over here, and I'm running out of space. Last step, we got to get rid of the 1 line, which is our -2 times x. How do I get rid of times?
Divide.
Divide by -2.
Property of equality.
It's in stereo now.
They gotta know their properties.
You're not wrong. What's a negative divided by a negative?
Positive.
Positive. My answer is going to be this +2 equals an x, because this is just a 1, and I don't need to worry about it. Is that the exact same thing we got over here?
Yep.
But what's another way we can write this?
X first, because sometimes you have to.
Because sometimes you have to. It's really good to know that these two are the exact same answer.
What property is that again?
What property is that, Mr. Craig?
It's a symmetric property
It
of
is the-
equalities.
He got it, you guys. He got it. All right, and I think that is the last one for this video. Is there a learning
That's
activity
it.
for this
We're
one?
good. Done. Put a fork in it.
Put a fork in it.